This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
For Software Engineering Radio, this is Robert Blumen. Today, I am joined by Björn Rabenstein. Björn is a production engineer at Soundcloud and one of the main Prometheus developers. Previously, he was a site reliability engineer at Google and a researcher in the field of molecular modeling. Björn, welcome to Software Engineering Radio.
Welcome. Thanks for having me.
It's great to have you. Today, Björn and I will be discussing site reliability engineering. And since I'll be saying that a lot, I will often say SRE. If you hear SRE, then that's what I meant. We will be discussing Björn's experience and also many ideas from the book Site Reliability Engineering, How Google Runs Production Systems, which came out earlier this year. Björn, would you like to say anything to the listeners about your background that I didn't already cover?
Yeah, kind of you got my life in a nutshell. So, I had two jobs in my life, like two conventional employments. The one is the current at SoundCloud, which I have my 3-year anniversary tomorrow, actually, which is kind of neat. And before that, I had like 7 and a bit years at Google as a site reliability engineer, as you said. And previously, I was just doing freelancing in the, late .com bubble or something. But originally, I'm a scientist. So originally, I wanted to just do the proper scientific research, not computer science, like real science. For some reason, I got stuck there and ended up in computing anyway.
Björn, I've been working in the field of DevOps for about a year now. But I've been hearing that term for 6 or 7 years. We have already done 2 shows on that topic, number 247 and 268 on infrastructure as code. I recommend those to the listener as background to this show. In the last year, I started hearing the term SRE. Is SRE another name for DevOps, or is there more to it than that?
That's a really good question. Definitely the term SRE was invented at Google internally way earlier. I think DevOps is like 2008 or something, the birth of the term. You have to correct me if I'm wrong. And I'm not sure when they came up with the term SRE at Google. I think Ben Traynor, who is kind of the head of the whole department, was hired in 2003. So I was interviewed in 2005 and joined the company in 2006. So it was already history in a way. So the term existed before, and I still remember I was kind of glad when this term DevOps appeared, because I could finally explain to people what I'm doing. Like, I thought, this is actually a neat explanation, right? I'm kind of a DevOps type at Google. But then I realized it's causing even more confusion. And I think that's not so much because there's such a difference between SRE and DevOps as terms. It's more like that DevOps covers so many things. Like, people understand a lot of different things when they say DevOps. So I guess you have treated that in the previous shows. I don't know them by detail, so can't say. But to be like a bit mean, I think many people, if they say DevOps, they basically mean, okay, we have devs and we have ops, and now they should get along well with each other, and we call that DevOps, which is obviously probably not what it should be. But it would also be very different from the Google SRE view. On the other hand, like especially now that I'm at SoundCloud, we have a particular approach to DevOps, which is more like, we don't really have devs, dedicated devs and dedicated ops. We are both. Like, everybody is both in a way, right? And that's another interpretation of DevOps, which is probably not what many people mean when they say it. And it's also different from what Google means if they say SRE. Yeah, so I guess there's an overlap, and they phrase it quite nicely in the book. In the introduction, there's a little box, pretty much in the beginning, where they explain the relationship between DevOps and SRE. I guess we can discuss it in a bit more detail, but perhaps that answers your initial question.
Yes, it does. We have, as you guessed, done some basic shows on DevOps that covered a lot of the ground. And I think your answer encapsulates that there may not be a complete agreement among everyone using these terms what they mean. I'd like to focus, because of this book and your experience, how does Google define SRE, and what is their take on it that is a bit different from the rest of the industry?
So I think there wasn't really a one-line definition. As I said, I was so glad when there was a term like DevOps, a catchy term you can tell people if they ask what you're doing. And in the book itself, they actually also discuss how difficult it was to explain to outsiders what SRE is. And now we have the book, so we can just tell them, read the book. It's no one-line explanation, right? There's a whole book about it. Obviously, you want something shorter, I guess. So I had this one line, I think it was Jamie Wilkinson, who is an SRE at Google, who is very much into monitoring. We might talk about that later. And I listened to a talk because it was about monitoring. And he said that in the introduction, SRE is if you take software engineers and let them design an operational function, something like that, right? So you're, and I think this is important to understand, that SRE is, in a way, it's a dedicated ops team, an SRE team, but they use software engineering techniques to approach the problem of ops, right? So perhaps that catches it. And I think in the SRE book, in that box, they say you could say SRE is a particular implementation of DevOps with some peculiarities, but in general, you could say that. It's a specific kind of DevOps. Yeah, so perhaps that catches a bit of it.
Okay, you're now talking about SREs apply a software development discipline to the problem of ops. What type of software do SREs develop, and how is it different than what we think of as the application?
Yeah, that's also a very good question, because where's the line? In practice, I think in a way SREs should be involved in the ideal case in the development of the application already, because SREs know how to run that application at scale in a maintainable fashion. So they certainly should have contributions there, or if it goes wrong, I've seen that as well, that there's a product developed, it's launched, and it just isn't sustainable in operation, right? And then basically SREs come back to you and try to fix it. But ideally, that's already taken care of when you launch. On the other hand, there's a lot of code you write. It's this infamous replace yourself with a small shell script. But in practice, obviously, the shell script is not really small, and it's probably also not a shell script all the time. I've seen shell script magicians at Google as well, but that's more an anti-pattern, right? If it's getting too complicated, you don't take a very big shell script. You take Python or even another language, whatever. There are so many things where you can just automate yourselves out of your job, essentially. So whenever something, you do it 3 times and it's redundant and it's stupid, then you should ask the machines to do it. And that's software development in a way. But then there's software, I would call infrastructure software, where the line gets really blurry. Let's say you want to develop a cluster management software, or you want to develop a monitoring system. And at Google, there were dedicated software engineering teams that developed that software, and they might have had an SRE team again. So there's again this line where even the infrastructure development is not per se SRE, but then the line gets blurry. For example, my team I was in at Google, they just happened to develop a kind of distributed cron, which was totally infrastructure software, but then it happened that the SRE team developed that software. So it's a blurry line, and if you go outside of Google, where you are at smaller scales, it's even much blurrier, and at SoundCloud the world looks completely different. So I've seen different worlds there, but yeah, It's in practice, sometimes you draw the line quite clearly and sometimes it's really an overlap.
I'm going to come back to SoundCloud a bit later, but for now I'd like to stick with Google. One of the main themes in the book was the way Google balances development work with operational and on-call work for its SRE. How did they do that?
So to, again, try to find a one-line thing, I guess that would be the 50% rule, which also applies to many other organizations or should apply. Essentially, if you're doing more than 50% of operational work in your work life, you are already in a non-sustainable state. So the rule was, as an SRE, you should be able to use at least 50% of your time, if it's more, even better, on like automating tasks, reducing tech debt, get yourself out of the hole you've dug before. And at most 50% would be time spent on call or just fighting fires, fixing things that just broke, right? And the idea behind that is your system usually grows, right? I mean, if you have a healthy business, Google or not, you want like 2x, 3x, 4x growth every year, and you never grow your engineering population by that factor, right? So if you are doing 50% operational work, next year you will do 100% operational work, and so you're completely there. And another year later, you will do 200% operational work, like you're running 60 hours a week or something, I don't know, and then you burn out and you give up, and that's the end of your business.
If I try to synthesize what it is you're saying and this book is saying about SRE, if I think of generation 0 in our awareness of these systems, you'd build an application and you give it to some guys and tell them to deploy it, figure out how to run it. And generation 1 is you start getting feedback from ops that you take into account during development. SRE is where the operational needs are fully integrated into the life cycle of software for the organization. Would that be a fair statement?
I guess you could, but it might also depend on, like in a pure Google view, it probably depends on your situation. Like back in my days, I don't know if that's more equilibrated these days. Back in my days, having SRE support for your product, like as a development team, you really wanted SRE support for your product. That was highly sought after because there were so few SREs relative to, let's say, classical software engineers. So like core products like search and ads and Gmail, they had for sure SRE support. But if you were like launching something more niche, then you would be probably completely in charge as a developer for running and deploying that product as well. Once you have that SRE support, I guess you have this kind of team that deals with things like deploying. I mean, there's also release engineering at Google. I'm also not sure now that I've been away from there for 3 years how that developed, which plays with each other. But yeah, like it's in a way where you say, let's say, one flavor of DevOps where developers are just very, very close to deployment and do it themselves or something. That would definitely be a slightly different approach from, let's say, a Google large-scale core product. Yeah, you also are a bit conservative if you make $2,000 a second. You don't just want to push a button and then everything goes down and you say, oops, let's roll back.
Sure, it requires some thought in advance to how you're going to keep that revenue stream going. DevOps may be a good description of what people are doing or the roots of the discipline. The term SRE contains the word reliability. That is another focus of the book. I wanted you to give me your take on Dickerson's hierarchy of reliability.
Yeah, that's a great one. So Dickerson is Mikey Dickerson, and the listeners might know him. He is the person who runs the US Digital Services. If that's the right name, I hope I got that right. He was actually the head of my sister team. Like I was in Dublin in an ads SRE team, and we had a sister team over there in California, and he was heading that team. So we had a lot of collaboration. And at some point he moved on, and it's a longer story. He told that story quite often. Now he is there at the White House at the US Digital Services, which is kind of an SRE team for the US government, if you want, right? And funny enough, if I remember that correctly, only when he had to explain all those principles that were in our DNA, he came up with this hierarchy of reliability. And that's modeled after the hierarchy of needs by, who was that guy?
Maslow.
Exactly, yeah. The psychologist, which is all about like the most noble human activities, are essentially the tip of the pyramid. And you can't like do self-actualization if you don't feed yourself, and if you don't feed yourself, even like being safe doesn't matter, right? It's this whole hierarchy where the most basic ones are actually the most important ones, and they are at the bottom, and in the pyramid they're the huge things, and then you put the smaller and more delicate things on top. And so Mikey created that hierarchy for reliability, and the bottom layer is the one I always remember because it's monitoring, which is my personal, let's say, special area as a Prometheus developer. But that was also where, like at Soundcloud, where you come into this growing company that runs into this problem with like running a growing, more and more complex system in a reliable fashion, and the first lack you realize is monitoring, and without monitoring, nothing else works.
Looking at a picture of Dickerson's hierarchy, so monitoring is the bottommost layer of that.
Yeah, and then I have the picture here as well. Now that we're talking about it, next is, I don't know it by heart, right? I stop at monitoring. But anyway, next is incident response, which like arguably is really closely connected. Then you have like a postmortem thing, root case analysis. I just remember like the whole idea of blameless postmortems, because that's, I think in many traditional companies, there's a lot of scaring people and blame them if something happens. That's like a very important thing at Google, that you have this mistakes are to be learned from and not to fire somebody. And then it goes on. Testing and release procedures. There we are. We talked about that. Capacity planning, development, and then the tip is the product itself, right? I mean, this is the one thing that people outside see and they think this is everything, but in reality, it's essentially the tip of the iceberg.
If I understand correctly, the parallel to Maslow's hierarchy, you can't take care of the higher levels. You cannot achieve the higher levels until you've solidified all of the lower levels, and a foundation in each one enables you to proceed to the next level. And Dickerson is observing the same kind of dependencies exist between these layers in the reliability world.
Exactly.
Is that correct?
Exactly.
Okay.
And that's interesting. If you even back then when I joined Google, I was kind of getting into this wonderland of science fiction. I don't know, like 10 years time warp. I'm now 10 years in the future, and I see how computing is done in the future. But like if you have this, I mean, Mikey had this in an extreme fashion. I think it's called brownfield, or you enter a field that is already pretty established but can't cope with the modern challenges. And then you have to explain to people, and you have to build it up from the base, right? And you start with monitoring. I guess SoundCloud, in my experience, was less brownfield because it is a pretty young and modern organization. But monitoring, like, it grew into this higher, larger scale, a lot of users, a lot of complexity. And then monitoring was definitely that paved the grounds to having a reliable site. And then you build up, you put one layer on top of another.
Yeah, it does make sense to me when I look at it, because without monitoring, you have no knowledge of what the system's doing. If you have monitoring, you need to respond when something goes wrong, otherwise it won't get fixed. Then after the fact, you need to do postmortem to understand why. And the next layer is testing. You need to have tests to prevent that same bug or similar bugs from getting back into production. So this is all making sense to me. Maybe when we get to the next layer, capacity planning, do you have a clear idea why that is the next layer above testing?
I don't have a spontaneous clear idea right now, but I mean, I guess that's a pretty high level function, right? I mean, if your site is on fire all the time and every deploy breaks everything, you don't even think about capacity planning. So it might also be something you only think about that. I mean, it's super important, of course, like every step in the hierarchy, and arguably the topmost one is the most important because your product is why you're doing all of that. But you can only even think about it once the other things are there, right? So capacity planning is like once your monitoring is in place, you can start to collect metrics like long term, and then you can start to think about capacity planning. You can start to project. You understand your system, how it's going, how it's scaling, and only then you can start with meaningful capacity planning.
I found in the book a very interesting discussion. There are ways of measuring reliability, and this question will not be so much about measurement. Let's assume we can measure reliability by uptime or error rates. The point was that you need to decide how much reliability you want or you want to pay for, and there is such a thing as too much reliability. What do they mean by that at Google when they talk about having too much reliability?
So I mean, the one thing I had this quite often, not only at Google and perhaps even more so like outside of it, when I talk to people who haven't seen that, when you start to set an SLO, like, I mean, not yet an SLA, like you are not signing a contract now, you want to find out what am I aiming for.
Could you define those two terms, SLO and SLA?
So SLA is the service level agreement. So that's essentially a like legal contract, or it's an internal within the company contract where you say, okay, we're serving at this level of whatever availability, reliability, throughput. That's what we commit to, and if we break it, I mean, between like different entities, you might be legally liable, but like this is the contract, right? The SLO is something you aim for. This is what we set as our objective, and then I mean the SLI is the service level indicator thing. That's the first thing when you even define what you are doing to measure your service level. And then you have the objective to know what you're aiming for, what you're designing your system for. And then as the last step, you agree, okay, this is our system, and we formally agree to keep that service level. And so the objective, that's the part where you could aim too high, right? Like people naively think the more reliable a service is, the better. But then you might over-engineer, right? If you go for an approach where you say, okay, just give me the latency as low as possible and give me as many nines as possible, this will influence your design, right? You get to a point where you over-engineer the system and you invest too much efforts, and you reduce your agility in a way, right? And that's the other term where that probably often plays a role, is this error budget thing, where you say, I mean, that's also the relationship between an SRE team and a developer team. You tell them it's actually fine to only have 3 nines or 4 nines because that's our SLO, right? And you have an error budget. You can play, you can do risky deploys to try something out as long as we keep our error budget. And once you reach your error budget, then like, okay, now that's it. We have to do more conservative from now on, and we cannot just do risky deploys. So it's actually, it's worth something to be able to do risky things that might create errors. You also get an advantage from that, and that's why it's really important to have an objective. And I had a very practical thing at SoundCloud. Like my first project at SoundCloud was actually suffering from a misunderstanding of the SLO. So we designed the whole system because an SLO was set, like every request has to be served in 100 milliseconds, right? And then we designed the whole system in a way to do that, and it had a 10 times larger resource footprint than it could have been. So later, another kind of the same service was implemented again with a different SLO in mind and used way less resources because it had a different SLO, right? So it really matters. It's not just better, it's not always better in a way.
Yeah. So we've been talking a lot about the Google experience, the Google book. You're now currently at SoundCloud. What did you bring from the SRE philosophy that you're able to apply in your current position at SoundCloud?
Yeah, it's kind of fascinating how much it actually is. I only realized that when that book came out, because I mean, there's on the testimonials page, like the very first page, you can see a quote of myself, how I kind of praised the book as my gospel that I'm preaching at work. I mean, I was surprised because the setup is so different and the whole organization is so different. So we are totally not an SRE team. We are doing quite different things, but there's so many lessons you could still apply. And it's nice to have this all codified, and I realize how much of those lessons I have applied at SoundCloud. So I don't even know where to start, but it's interesting how you can use those little concepts and ideas even in a pretty different setup.
Why don't you pick one example of a SRE concept that you successfully applied at SoundCloud?
Yeah, I mean, I'm totally biased to always talk about monitoring. Okay, it's the basis of the reliability pyramid or reliability hierarchy, according to Mikey. That was even before I joined SoundCloud. There were a bunch of ex-Google SREs that joined SoundCloud for some reason at the same time. It was not even coordinated. It just happened. And their first big problem was indeed monitoring. Like, this need wasn't met. They had no idea where to even start, where to see what's going on. And I mean, that wasn't only felt by them, but by everybody. SoundCloud was getting more complex. They started this microservice thing, and things started to scale up and getting complicated, and nobody had an insight what's actually going on here. And so that was, for them, the reason to start even a monitoring project, which is Prometheus, right? So that they could get monitoring in a way they knew from Google, and that would allow them to apply even the principles of site reliability engineering. And perhaps one thing we might talk about Oncall, because that's probably something that many people run into. Traditional approaches of alerting is like, a server is down. Like, I set up my Nagios check, and if the server doesn't ping anymore, I wake somebody up to reboot it or something, right?
You just now mentioned Oncall. For listeners who are not SREs, tell us about what Oncall is as part of SRE job description.
So Oncall, obviously, if you're on call, you carry a pager, you get alerts from the machines if they need human intervention. An SRE team at Google is usually doing the first level on-call support for their product. So let's say if you're on ads SRE, back in my days, we were on call for everything that had ads. It got later when everything grew bigger. We had more specialized teams. For developers, that's great because they get first level support for their product. Developers still are on call in a secondary or tertiary position where if the SRE can't deal with the problem, they might get woken up. But it's definitely something that's pretty crucial for SRE. At the same time, remember the 50% rule. You are never supposed to invest more than 50% of your time into those operational concerns. Also, SREs are not pager monkeys. That's a common misunderstanding. Also, parallels DevOps misunderstanding, I think, when you think, we have our DevOps team and they are pager monkeys, right? So it's a bit smarter than that. But you are definitely... on-call is an important part of your job.
Okay. And I interrupted your discussion of how this came about at SoundCloud. You were setting up on-call.
Yeah, that's the example where monitoring and on-call plays into each other. So we were there where you basically get a page if a single server dies. And your monitoring system mirrors that idea, right? Because you have your Nagios probe that pings the server. If the server goes down, you get a page. So now you scale and you have thousands of servers. They might not even be physical servers. They might be in the cloud and virtual machines or whatnot. And then at some point you realize, if I wake somebody up whenever a server dies, I will wake somebody up all the time. And that's something that is not sustainable. And you can't just solve it by coming back to that, a team of pager monkeys that are just paid for getting paged all the time. You also have already designed your system probably in a way that it can sustain single host failure, for example, right? So there's where you get into an area where you start to think, okay, so when should I actually wake up a human being? It's like, it's this metaphor where like the computers are essentially the normal mortal beings, and they call the superheroes if they can't cope, right? So, and the superheroes are the humans that get paged. So when should a machine call a human in for emergency? And then you start thinking, okay, I need a different view. I cannot just think about, okay, a machine has failed. That's probably a problem. I have to look at something like, is my user experience affected? Because if I have a nice cluster management solution, a distributed system that might perfectly cope with single machine failures, my user experience is fine, right? At some point, of course, somebody should check out what's going on with that machine, but that can be during work hours, whatever, right? I don't have to wake somebody up to react within 2 or 3 minutes. So you get into this idea of what we call symptom-based alerting. So you alert if something is wrong with your user experience, or something is imminent to go wrong with your user experience. That's the best case, when you know for sure it will happen, but it hasn't happened yet. And the other thing is the cause-based alerting, where you think, okay, a machine goes down, that might be a reason for a possible failure, or a rec switch is broken or something, right? Where you alert on something that might or might not be the problem in the end, like causing a problem. And that's, for example, a very different paradigm, how to alert, when to wake up people. And now we come back to the hierarchies of reliability. You need this basic level of monitoring. Your monitoring system must be able to tell you that, right? If your monitoring system is only able to tell you that a machine doesn't ping anymore, you will not be able to set something up like that.
Yeah, and I want to interject here. You mentioned Prometheus monitoring. We do have a show recorded on Prometheus. It hasn't been published yet at the time I'm recording this show. I believe it will be 270, but anyone who'd like to learn more specifically about Prometheus, you can find it on the SE Radio website. You've been talking a lot about what should be monitored, about monitoring at different layers of the stack, different types of performance. In the book, they discuss the concept of Google's 4 golden signals. What are the 4 signals, and why are they very critical things to monitor?
So they mentioned those 4 golden signals in the book. It's like we can read it like the Bible, chapter 6. I mean, there
Verse 2.
Exactly. There are different opinions what like the most important things to monitor are, but there's a huge overlap. Even if there are like different opinions in detail, you will always come back if you ask the experts. There's a common core, right? We can just take them from the book, and the 4 golden signals. I actually have it here. My Bible is always with me. So the first one is latency. So how long does it take to serve a request? Then you have traffic. That's how many requests you're serving. Errors are how many of them result in an error. And then saturation is how full your service is, meaning what's actually your capacity. I mean, you might be serving quite fine right now, but if you increase your traffic by 10%, you might start to fail. And then you think about redundancy. And that's, of course, also important for capacity planning, but also like if you have the luxury of multiple data centers globally, how do you route traffic? When do you decide that you have not enough redundancy now and you should do something? Can you afford to just send a data center into maintenance right now? Things like that.
So saturation, that could be at any level. For example, we could have CPU saturation or on a single instance, or I/O saturation on a particular storage device, all the way up to what you think is a high-level measure of capacity of a larger system.
Yeah, or
is that correct?
Pretty profane, how full is your disk, right?
I asked you, how did you apply SRE concepts from Google at SoundCloud? Were there things you tried to apply from Google that it turns out they didn't work at SoundCloud because it's a different job and different organization, conditions are different?
Yeah, so those parts were, I would say, was mostly not a technical thing. Like technical ideas from the SRE world almost always apply to other, like if you're at a minimum scale, things just apply. It's like a natural law, but there's a huge organizational and, let's say, cultural thing about it. I said before how much sought after SRE support at Google was. So developer teams really wanted SREs. So that gave them a bit of, let's say, authority. They could say, okay, if we support your service has to behave in a certain way. And if it doesn't behave that way, then we won't support it, or we will give the pager, and things like that happen. And that's, in a way, it empowers you. And that setup wasn't just there at SoundCloud. For one, like the scale of SoundCloud, although we scale a lot of traffic and serve a lot of features, is so different. You couldn't have a dedicated SRE team for every, let's say, product we have, right? SoundCloud is 2 orders of magnitude smaller in terms of engineering population than something like Google or Facebook, but we don't have 2 orders of magnitude fewer products, right? Perhaps you have a 1/10 of the products, right? But it's like you still have a customer-facing thing, a billing thing, something for the users. All those things are there even at a smaller scale, and you cannot just have a dedicated SRE team just for ads, right?
So the ratios are different. You might be 100 times less on some scales, but 10 times less on other scales, so you can't have the same ratios consistent throughout with what you see at Google.
Yeah, that makes a big difference. And in this concrete example, we couldn't just say, oh, we are building up an SRE team now, and the SRE team will take your pager for the whole company, right? So that just wasn't feasible. And in reverse, that means there was nothing where the SRE team could say, okay, if you're not doing it this and that way, we will just not take the pager, because they were not going to take the pager, right? So then I think that was before my time. They tried to, like, let's say, okay, we have proper SREs, but they are like embedded in the smaller teams we have. Like, we send an SRE into this team, and they should use their magic wand to make everything reliable. And that didn't really work either. There was already an established culture, how things were done. And there's like, you cannot just, like, your culture is usually also, it's there for a reason, and it's precious, and you cannot just change everything to a different culture. I mean, not at least if there's, yeah, I guess there's needed to be like desperate need that you need to change the culture for some reason because it's dysfunctional. But it wasn't dysfunctional at SoundCloud, right? We had a precious culture, and in the end, things worked out quite differently. In some way, nowadays, everybody at SoundCloud is an SRE in a way, because we follow this approach where, what I said in the beginning, the devs are also ops. You build it, you run it. So what happened in the end is not that we build up a dedicated SRE team that would work like a Google SRE team, but it was more like that we fostered SRE approaches throughout the engineering organization. And now everybody is, in a way, a little SRE in the company.
You're talking about the relationship between the SRE team, or maybe the SRE role if it's not a team, and development, and this negotiation about who is going to carry the pager, who owns alerts. How do you find the right division of responsibilities within an organization between what goes to SRE and what goes to developers?
So in the Google approach, if you have the properly supported SRE supported servers, then all the alerts go to SREs first, right? And for important services, they might have a secondary rotation in case a page falls through, but only then there's a tertiary on-call where the developer is paged. And ideally, a page never falls through automatically. It's just that the SRE, if there's something where you think, okay, this is somebody changed something in the code and I don't understand it, and now I really need a particular developer, then you page the developers. In my case, in my personal case, we were in Europe, in Dublin, and were in charge of way more different little products than the corresponding team in California, because we were the smaller team. We were covering more while they were asleep, and we had a lot of different developer teams that we needed to escalate to if needed. Ideally not, of course, we would be able to handle it on our own. But again, that's at smaller scales, like Soundcloud scale, that's just not going to happen. So at Soundcloud, there is essentially our team called production engineering, not site reliability engineering. We don't carry the pager for any product. We carry the pager for the systems we are in charge of directly, like let's say cluster management, monitoring, infrastructure stuff. And then, but whatever you develop, whatever you build, you run it, you are also on call for it. So it's a completely different layout of responsibilities.
I was recently at a talk by Gene Kim, who's one of the leading thinkers and writers in the DevOps space. He posted a slide which said when we started paging developers at 2 a.m., problems got fixed very quickly. Now, that sounds a little bit cynical and maybe manipulative, but is that a good way for SRE and development to work together?
I mean, if you have to apply that pressure, I guess I would hate it, like from a personal perspective. But I think there are three different scenarios we have now here in the discussion. The one is essentially what that expression is referring to. You have an existing engineering organization. You have like ops people that get paged all the time because developers deploy software, throw it over the wall, and it doesn't work, right? And then you think, okay, we just page the developers at 2 a.m., then they will fix it. At Google, the corresponding situation is probably that a software doesn't really work according to standards, and then the SREs, as a last resort, can threaten to give back the pager and stop to support that system. At SoundCloud, there was again a different setup, because that kind of pager monkey thing, I think they might have tried it one point, but it really didn't exist when I came there. It was really, you build it, you run it, was already reality. So people had more the opposite problem, that we had two small teams that shared an on-call rotation because they got really in love with their software, and you had like 2 or 3 people that were the only one that knew about that particular service, and they were doing the on-call. So essentially a person was on call whatever, Monday to Wednesday, and the other person was on call Thursday to Sunday, and they had no life anymore, but it was their software, they knew everything about it. That was kind of it was doing it wrong in the other direction, where the developers were too closely related to that, which couldn't really happen in a Google-style SRE setup, because there you hand over your support to an SRE team. So you must be sure everything is documented nicely. Those are reasonably smart engineers, but they have to learn what's going on here. So you kind of are forced to make it approachable for others. And at SoundCloud, it was more the problem that this didn't work at all. But that has changed. Like, we improved a lot there, that now we have bigger on-call rotations. People transfer that knowledge to other people, so more people are capable to deal with a certain outage in a certain service.
Yeah, and this is something that is necessary for an organization to scale, is that the knowledge has to be transferred and shared among more people. You did just now mention documentation. Talk about the role of documentation in sharing operational knowledge.
Yeah, that's definitely a hot topic, starting from designing a new product or a new iteration on an existing one. Google has a really strong culture of writing design docs, reviewing design docs in an informal fashion, like we had a design doc reading club in Dublin, but there is also formal review of design docs. And Soundcloud was much more, in a way, I don't know, agile, capital A or not, was more like, okay, let's just do it, which came from this startup culture where you're really a small group of people, everybody knew each other, and like sharing information was not an issue. And then you grow into a bigger organization. And this is also, I guess, something where SoundCloud has matured a lot. And after a few incidents that were caused by not having shared information enough or starting to develop something without asking that other person 2 floors down that would actually have known a lot about that particular problem. And we have a way better sharing culture. Let's say we write, I think we call it RFCs and not design docs, but it's essentially a similar thing. So that's from the start on. And then, of course, operational documentation is really important. That's also something where your monitoring system, to come back to that again, can help you. For example, we have a nice way of displaying a documentation link with an alert. Like you get an alert, and might be that alert of that sister team you are now on call for because there are only 2 people, but the alert already gives you a link to their runbooks. So what's going on if that fires? What's the background, and what can I do to handle that situation? And that's also very similar to Google, despite the complete different in structure. We had also a really strong culture of having alerting documentation for incidents.
You just now used this term runbook, where if I understand, if I'm on call, I get an alert that the foo bar is down, and here's a link to the runbook, which is documentation site, and it would say, check the queue length, make sure the database is running, look in the error log. If you see this and this, try restarting, those type of things. Is that what a runbook is?
Yes, pretty much. I think in the SRE book, they call it playbook. So there are, again, different words for essentially the same thing. I also like to have to write down runbooks because that's kind of a litmus test if your response is essentially scriptable. If your runbook is, that happens all the time, just turn it off and on again, restart that service, that's a clear hint for, okay, perhaps you can actually put that into software and let the machines do it and don't wake up a human being. While if you see this is actually a guideline for an intelligent response, right? Where you see, okay, I actually have to use my common sense and my intelligence to find out what's going on here, then it's a good runbook, right? I mean, the runbook. You can't blame the runbook. If you have set up something where the runbook is a script, you should turn it into a script. That's essentially the lesson.
Sure. And that very much goes along with the theme in the book, which they call removing toil, and by another name, automate all the things.
Yup.
Okay, Bjorn, well, we've talked a lot about Google's approach and how it can or can't be applied elsewhere. Suppose I'm a bit of a skeptic and I say this would be great if we had all this money and all these people to develop all these operational systems, but organizations don't all have the same resources as Google, and it may be difficult to get their head above water and focus on automating things because everything's breaking all the time. How can an organization that sees themselves as not being like Google at all, what can they apply from the Google philosophy?
I mean, I guess SoundCloud is a pretty good case study for exactly that problem. So SoundCloud has 100-something engineers. I don't know the exact number right now, but it's, if you know like the tech scene and you know like how many engineers, let's say typical competitors of SoundCloud have, you would be surprised how small the organization is and how much they get done. But so we are definitely in that situation where we are resource-wise, where resource is a very general term, including humans, where we have not a lot to spend and we still have to keep the system running. And we were pretty much in that state where the old approach, like you can read that everywhere. Monolithic Ruby on Rails application for the site. It just didn't scale in various ways, so something had to be done. The decision was to go microservices, and that's really bold to do, like under full steam. So that took it was just a lot of work to do. And at the same time, there's constant pressure to launch new features because it's a hard competition. So you had exactly what you were thinking about, I guess. So what can we even do? Like, our site is falling apart all the time. We have new features to launch. We have new infrastructure to implement. And yeah, still, we kind of pulled it off. We are pretty reliable by now. So I think it's difficult to just give a rule of thumb what you can do, because of course you as an engineer, I just push back if like I'm asked to implement the next big feature, and I think we have way too much tech debt. I mean, you have to push back, I guess, but sometimes there's just a business need. If you don't implement that feature, we are out of business. So yeah, it's hard, but I guess you need to make yourself heard so that you have the right, you weigh all the things you have to take into account and come to the right decision. But like, dying of tech debt is definitely something that can easily happen. And I guess for people outside of an engineering organization, it's really hard to realize. They see engineering as a black box. They can't know what's going on. And you have to explain that quite carefully, that you need some air to get out of this 50% trap, right? When the 50% toil become 100% and then 200%, and then there's just no way back. Like, you should try, if you go over the 50%, you should really try hard to get the way out of that. And yeah, it might be hard, but like in the Soundcloud case, we have proven it's possible.
Yeah, and I do want to mention show 224 we did about technical debt, which addresses some of those issues. Now, Bjorn, for last question before we start wrapping up, you and I were chatting offline about, you have a background in molecular science, and I'm working in the SRE or DevOps field. I had my education in physics, and one of my coworkers also had a physics background. You said it's not uncommon to meet people in the SRE world who have a non-conventional background, meaning, I suppose, outside of computer science. Do you have any thoughts on why that might be?
Yeah, that's something I found, like when I never applied myself at Google, like I would not have dared. It was like, okay, this is what computer science graduates from Stanford do or something. But then once I was inside, I realized, okay, so there are like a lot of physicists, chemists, like myself, or like historians, or people who have never studied anything, and they just turned out that they have the talent. And of course, I mean, they had brought also some experience. But I think, I mean, what recruiters always told me, it's so hard to hire for SRE because you want this software engineering mindset combined with, yeah, I'm totally not afraid of thinking about network packets or whatever, running a script or I don't know, like have this combined skill set of a software engineer that also is kind of a sysadmin type and has all those things in their DNA as well. And I could imagine, I mean, that's pure speculation, if you're coming from, let's say, you do this physics or chemistry thing, that you are more likely to develop those skills. Like in my case, I'm a biochemist, and we happen to do like simulations, and we needed a lot of computing power, and the university was like didn't have a lot of budget, so we started to build back then in the 90s like a Beowulf computing cluster. And that started with, okay, we don't even have like technicians that would help us assemble that thing, so we now have to go to shops and get like 3 offers from different shops and then build it all together. And then the Linux network drivers were a bit problematic with a lot of traffic back then or whatever. Like, so you started to do everything. Like I think nowadays the buzzword is full stack. So you are actually a physicist or a chemist, but you start to buy computer hardware and hack kernel drivers, and then in the end you also write the software that runs the simulation, and you have this whole view, and also you have to present results in the end at a conference. And perhaps that's a nice like education, or it sharpens your mind for what you need in an SRE setting.
Bjorn, is there anywhere on the web where listeners could go if they would like to learn more about you?
Yeah, just Google me, I guess. I mean, I don't exist kind of because I don't have a Twitter handle, but like recently with the with Prometheus becoming so popular, the Prometheus folks get invited to conferences a lot. So, and I think my name is pretty unique on the internet. There might be one or two others with that name, but I guess I'm more popular than them. So you can listen to loads of talks about Prometheus, or also like there was SRECon in Dublin this year. There I gave a nice talk about alerting that pretty much resonates with the topics we covered here. So yeah, definitely you can find a lot about that.
Great. Bjorn, thank you so much for speaking to Software Engineering Radio.
All right, thank you too.
Thank you, listeners, for downloading the show. You can send us feedback multiple ways. You can direct message us on Twitter at SE Radio, on our Facebook group or LinkedIn group, or email us team@se-radio.net. For Software Engineering Radio, this has been Robert Blumen.
Getting software to your users quickly and reliably is the most important part of being a software engineer. SnapCI's cloud-based continuous integration and continuous deployment tool lets you set up in minutes with your GitHub account, and within a few clicks will have your first pipeline running. Discover and fix your bugs quickly before pushing to production by setting up stages from simple ones to complex that run automatically when you push your changes. Need more speed? Run tests in parallel with expanded workers and get your feedback fast. Deploy to Heroku, AWS, and more. We even integrate with Slack to give you updates on your builds. Go to snap.ci/softwareradio and build, test, and deploy free for 30 days. SnapCI embodies the lessons that ThoughtWorks has learned from 20 years of software deployment. The same lessons that have been written about by Martin Fowler and Jez Humble. Check it out at snap.ci/softwareradio. Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can write comments on each episode on the website or write a review on iTunes. Mention or message us on Twitter at SE Radio, or search for the Software Engineering Radio group on LinkedIn, Google+, or Facebook. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Thanks again for your support.